Hi everyone. Today we're going to study graphical method of solution of a pair of linear equations. Let's begin with pair of linear equations. We can summarize the behavior of lines representing a pair of linear equations in two variables and the existence of solutions as follows. First, the lines may intersect in a single point. We call this consistent pair of equations. In this case, the pair of equations has a unique solution. Second possibility, the lines may be parallel. We call this now inconsistent pair of equations. In this case, the equations have no solution. Third possibility, the lines may be coincident. We call them dependent pair of equations. In this case, the equations have infinitely many solutions. Let us see now the relationship of coefficients of pair of linear equations. Given the lines represented by the pair of equations, a sub 1x plus b sub 1y plus c sub 1 equals 0. Second equation is a sub 2x plus b sub 2y plus c sub 2 equals 0. These lines, we call them intersecting lines. If a sub 1 over a sub 2 is not equal to b sub 1 over b sub 2. Or we call them coincident lines. If a sub 1 over a sub 2 equals b sub 1 over b sub 2 equals c sub 1 over c sub 2. Third possibility, this pair of equations are parallel lines. If a sub 1 over a sub 2 equals b sub 1 over b sub 2 is not equal to c sub 1 over c sub 2. Example 1. Solve graphically. X plus 3y equals 6. 2x minus 3y equals 12. Let us identify any 2 points of each of the lines. Let's begin with the first equation. This is the table for the first equation. This is the row for x, this is the row for y. This equation here is the rearrangement of this equation 1, whereas y is isolated on the left. So we have here y equals 6 minus x over 3. Then we assign 0 for the x. We substitute 0 in this equation, then we will get the value of y as 2. Next, we can assign 0 for the y. We substitute the 0 to this y, then we will get the value of x as 6. So for the first equation, the 2 points are 0, 2 and 6, 0. Now, the second equation. This is our table. This is the row for x, this is the row for y. For the row for y, this equation here, simply we rearrange our equation 2 such that the variable y is alone on the left. So we have y equals 2x minus 12 over 3. Then we assign 0 for the x. We substitute the 0 to this equation. Then we will get the value of y as negative 4. Then we assign 3 for the x. We substitute this 3 to this equation. The value of y then will be negative 2. So the 2 points for the second equation are 0, negative 4, and 3, negative 2. Now let us plot the corresponding points and connect them with a line. These are now the 2 lines. This is the first line. This is the second line. Observe that the point B with coordinates 6, 0 is the point of intersection of the two lines. So the solution is x equals 6 and y equals 0. Also, the given pair of equations is consistent. Example 2. Find whether the following pair of equations has no solution, unique solution, or infinitely many solutions. 5x minus 8y plus 1 equals 0. This is the first equation. Second equation, 3x minus 24 over 5y plus 3 over 5 equals 0. Considering the second equation, we have fractions. Let us multiply the second equation by 5 over 3. So it becomes like this. The 3x times 5 over 3, we will get 5x. The negative 24 over 5y times 5 over 3, the answer is negative 8y. Plus, the 3 over 5 times 5 over 3 is positive 1 equals 0 times 5 over 3 is 0. Observing the resulting equation, this is the same as equation 1. Hence, the two lines are coincident. Therefore, equations 1 and 2 have infinitely many solutions. Example 3. Champa bought some pants and skirts. The number of skirts is 2 less than twice the number of pants purchased. Also, the number of skirts is 4 less than 4 times the number of pants purchased. How many pants and skirts did Champa buy? We let x to be the number of pants. We let y to be the number of skirts. For the first condition, it says the number of skirts is 2 less than twice the number of pants purchased. So we write here y equals 2x minus 2. Condition 2. The number of skirts is 4 less than 4 times the number of pants purchased. So we have y equals 4x minus 4. Then let us draw the lines. For the first line, we have this table. This is the row for x, this is the row for y. Let us assign values for x. Let's say 2. Let's substitute number 2 to this equation. Then we can solve for y, and that is 2. Let's assign 0 for x. We substitute 0 to this equation, and the value of y will be negative 2. So the 2 points for the line 1 are 2, 2, and 0, negative 2. What about the second equation? This is the table. Row for x, row for y. Let us assign values for x. Let's say 0. We substitute 0 to this equation, we can get the value of y as negative 4. Also, we can assign 0 for the y. We substitute 0 to the y here, and the value of x is positive 1. Therefore, the 2 points for the second equation are 0, negative 4, and 1, 0. Let us now plot the points and connect. These are now the two lines. This is the first line, and this is the second line. Observe that the point Q, the 1, 0, is the point of intersection. Thus, Champa bought 1 pants and 0 skirts.